Welcome to our course Loss Function, and in this part of our course we're going to have the mean absolute error, or what we call the L1 loss. So there are things to consider when we want to choose what kind of loss function we're going to implement in our project. So first of all, we have to understand that the kind of loss function to choose depends on the kind of algorithm that we're going to use. As what we have known, we have two major categories, the regression and the classification. And for each one, there is certain loss functions to use, and we're going to have them one by one. So first of all, what is a loss function? So loss function evaluates how a certain algorithm models the data. So in short, it tells you if this particular model performs better as far as your data is concerned. And how to do that? You have to understand the deviation between the target and the real value. So when the deviation is high, then the loss function is also too large. The opposite also comes into play when, for example, the deviation is small, which means also that the loss function is small. You would want to ask me, what would be the case if, for example, we have a very high standard deviation or deviation? Do we have any solution for that? So the solution to reduce the error in a prediction is to use the optimization function. So what is this mean absolute error? How do we calculate that? So we have this formula that would tell you how to do the calculation. So very simple. We just take the average of the absolute differences between the prediction and the actual observation. So the yi or y sub I here is the actual observation, and this one, the y hat I here, is the prediction or predicted value. And of course, we have to divide that by n, or the number of enters in the population or in the sample. So the small n here is actually the sample. And if you want to take the number of the whole population, then we have the big N. Just like your mean squared error, MAE, in short, measures the magnitude of error without considering their direction. So that means we can have it the positive or the negative. The direction can be up or down depending on the value of the magnitude. Mean absolute error, unlike your MSE, needs more complicated tools. Like, for example, we have the linear programming so as we can compute the gradient. This one actually makes MAE more interesting and challenging than the MSE, which is, as we have known, this is MSE is actually more simple or simpler than the MAE. So if you want to know more about the linear programming, there are actually a lot of tutorial videos that you could see on the internet, especially on YouTube, on how to do the linear programming. So it's very much appreciated if you could do that on your own. So you would be able to truly understand how to do this MAE using the linear programming. But the good thing about the MAE is that it is more robust to outliers. And the reason for that is, unlike your MSA, wherein we square the difference in value, so in this case, we do not use that. So instead, what we do here is we just take the absolute difference between the predictions and the actual observations. Always remember that the keyword here is absolute, so meaning to say we would not get any negative values. Do you want to know more about this channel? Just click these cards. We do have a lot of free data science courses for free, like Machine Learning Essentials, Deep Learning Mathematics, and a lot more. Here, you can always learn an upskill for free.